Human head. This is the first time a pristine sample has been collected from the surface of an asteroid. Samples from 4.5 billion years ago. May 2021, NES OSIRIS mission began its 1.9 billion kilometer return journey, bringing asteroid dust and rocks back to Earth. 2 years and 4 months later, sample return capsule. It will re-enter the Earth's atmosphere in September 2023. Speeding at over 44,000 kilometers per hour. Marks an extraordinary achievement in space exploration. It's like an ancient time capsule, carrying material from our early solar system. Samples collected from the asteroid Bennu. Let scientists uncover the secrets of this asteroid. Evidence of origin, possibly from a water world, and expand our understanding of the history of the solar system. So, what secrets do Bennu's rocks and dust reveal? This is very important for our understanding of the solar system and the origin of life. What helps? OSIRIS detector, such as how to cross 1.9 billion kilometers for the acquisition mission, launched in September 2016. Go to the name 101,955 BEM's Forbidden Asteroid. It's been an incredible journey. He not only completed the task, also sent back high-resolution images from Bennu's surface. After 7 years of anticipation, space travel data, and sample collection, the OSIRIS probe returns to Earth. Return its special cargo. When the spacecraft is approximately 100,000 kilometers, he returned the sample to the capsule on September 24, 2023, into the atmosphere. Then the OSIRIS probe fires the thrusters to avoid a collision with the Earth and start a new task. We'll talk more about that later. This carefully calculated maneuver, it must be within the narrow window of time. Do it from the right angle. To return to the capsule, hit the western United States, a target of approximately 600 square kilometers in the desert of Tashu. A few weeks later, scientists at the NASA Johnson Space Center, scientists open the lid. 70 grams of dark gray rock exposed outside the sample crown, stone and dust. These materials are then used by border herders and divided into smaller samples. At least 70% of the materials will be preserved in their original state, so that future generations have the opportunity to conduct research. And the remaining material, there will be more than 200 scientists worldwide, and labs all over the place had the opportunity to work on Bennu asteroid debris. So, what's so special about this handful of space dirt? Imagine that, able to develop, examine a piece of our solar system's ancient past, a story about the origin of life and the early days. Period solar system. Sample clue. Scientists for the first time saw additional asteroids. Soil sample. It's called regolith. Although Bay, slave probably 1 billion to 2 billion years ago, fractured on a bigger asteroid. But its current chemical composition and mineralogy, already 4.5 billion years ago. Due to the fact that its composition has remained relatively unchanged, Bennu includes, on our planet, primitive ingredients that existed before they existed. Bennu's sample contained the so-called presolar grains. These were condensed before our sun formed. Junction microscopic crystals. According to the composition of these presolar grains, we can understand, before our own solar system formed, the types of stars that exist. The more massive the star, the more elements it can integrate. For example, low mass and medium mass stars are made of hydrogen. Elements such as hydrogen fusion into harm to burn. It may eventually incorporate heavier elements, such as carbon and nitrogen. Massive stars can fuse heavier elements, like a silica. Here's the thing. These massive stars can be nova explosion, save their lives, creating elements heavier than iron. Because these come from constant star fusion, elements are all over the universe and recycled, form new stars, asteroids, and planets. We can do this by looking at these presolar grains. To learn about the ancient building blocks of our solar system, cosmic chemist at the University of Arizona, also Austrian, Pierre, a member of the CIRRUS probe team, Anker said, preliminary analysis of these presolar grains shows evidence of small and medium-sized stars. There is also evidence of supernova. This supports the progress of our solar system. Cheng was killed before. Stars of different sizes. Rich ideas. Preliminary analysis of asteroid samples revealed to be rich in carbon, but with the dust of organic compounds. These ingredients, it's a fundamental part of life. NASA's OSIRIS probe science team. Bennu was also found in the sample. Evidence of the existence of water in the past, in the form of aqueous clay minerals. The clay minerals in these samples certificate. It was confirmed that scientists had previously studied Bennu's spectrum, the consistency observed in the survey. They show that Bennu may originated from larger celestial bodies that once contained water. But these ingredients of life, how did it appear in a seemingly poor on the asteroid? When? Why is there evidence of water? Turns out, these essential ingredients for life are abundant in the universe. Rich planet. Scientists and astronomers, already in our solar system. Milky Way. Organic compounds identified in interstellar space. We are on asteroids and meteorite moons. Nebula in a galaxy and further afield. These compounds have been found. They form the building blocks of life. All you need is oxygen, the combination of carbon and nitrogen. They are the number of atoms in the universe. The third, fourth, and fifth elements are abundant. These elements are produced inside stars, and from those ancient traditions spread throughout the universe. We are made of stars. From what we have learned, the substance of life is abundant, but the presence of amino acids and other organic compounds do not mean life has arisen in these places. In fact, without an atmosphere, temperatures range from a chilly -73 degrees Celsius to a searing 116 degrees centigrade. Bennu, it's not a good place for life. On the contrary, the presence of organic compounds means that the building blocks of life seem to be abundant in the universe. Rich. Bennu is further evidence of this. Because of these minerals, may have provided information about biology before, chemical reaction clues. And here's what's interesting. To the planets of the Natural History Museum in London, scientists Sarah Russell and Osiris. Scientists like the detection team members say, the sample is mainly composed of water and minerals. This shows that Bennu, possible, was once part of a larger celestial body. This celestial body contains water. The sample is full of, when water exists, evidence of dynamic changes over time, such as clay minerals or salts left after water evaporates. It contains a mineral called serpentine. This rock, stones are with us in the mid-ocean poles of the Earth. The rocks found are similar. These mid-ocean poles, it's meltwater rising up from inside the Earth and encounter water. New crust formed along the ocean floor. Bennu's regolith. It also contains a type of iron sulfur called pyrite compound material. This material can be sprayed on hot leaves on Earth. Formation near the mouth. And here's what's even more surprising. Osiris detector. The scientific team found phosphate in the samples. It's a building block of DNA. Therefore, it is also a part of life on Earth. The presence of these water-soluble phosphates indicates that, billions of years ago, Bennu could be a bigger one, part of a water-soaked mud ball. Even one with active geology and abundance. A world rich in organic compounds, although there is not enough evidence to conclude that Bennu conclusions from an ancient water world. But geologists at Rowan University, also OSIRIS, probe mission sample scientist Harold Connolly says, the evidence of warm water in the sample over time indicates that Bennu's mother is at least 10 kilometers wide, even bigger. Although more research is being conducted to further study these signs. But imagine this, Bennu may have originated from a much larger asteroid, or one with the primitive Earth, or some ice in our solar system. Satellites covering the ocean, such as Enceladus or Europa, round stars that share some important characteristics. It's unbelievable. OSIRIS probe data and samples. Scientists will be busy in the coming years. Because planetary scientists, geologists, astrobiologists, chemists, and interdisciplinary research teams keep studying this X from Bennu. Unknown samples. Although our understanding of the solar system and the formation of our planets already have a pretty good understanding. But this provides us with a more accurate opportunities to validate and adjust our current knowledge and explore thanks to the OSIRIS probe mission. The answers to possible new questions. The stellar nebulae that make up our sun and planets. Did they all come from an ancient star? Or from multiple generations of stars or different types of stars? Where did Bennu's mother form? What material is it made of? During the formation and early existence of the Earth. Some of his water or whether organic compounds come from asteroids. These are just the hopes of scientists in the coming years with the Bennu sample. Clarify a few of the frequently asked questions. As for the mission of the spacecraft, they didn't end there. About 20 minutes after releasing the BEM capsule, the OSIRIS spacecraft ignited its engines, sent it on a new trajectory and a new mission. It's now called the OSIRIS Apophis mission. In response to its new goals, the spacecraft will travel to and explore a different type of asteroid, the asteroid Apophis. He will arrive in 2029. From June 2029, he will embark on an 18-month campaign, mapping the surface of an asteroid, analyze its chemical composition, and watch Apophis approach the Earth. Any changes that occur? Finally, the spacecraft will repeat its mission at Bennu. One of the most impressive thrills of the mission. On the surface of the asteroid, dive within 16 feet and ignite the thrusters to stir up rocks and dust. It's different from being angry, Apophis mission. No samples will be collected from the asteroid Apophis. But this move will give us an opportunity. Here's another asteroid coming in. Substance beneath the surface. You've probably heard of it. Asteroid enslaved. It could collide with Earth in 160 years. Although this is a very remote possibility, less than a 1,700th, so there's nothing to worry about. But aside from the scientific investigation surrounding the returned samples, OSIRIS mission to Bennu, it also provided scientists with excellent, accurate tracking information. This will significantly reduce concerns about Bennu, the uncertainty of the future trajectory. Preliminary analysis of the Bennu sample exceeded our expectations in several ways. It was formed 4.56 billion years ago, older than the Earth itself. This piece falls. The stone fell to the present North 1 million years ago. Scandinavia. His octahedral form shattered on impact. There are currently about 40 known, held by various institutions around the world. This is one of the oldest meteorites. I am very much looking forward to the upcoming tasks of various countries. Bring new surprises. Thanks for watching. Welcome and leave a comment for discussion.